So here it has been told to find the equation of the plane, pi1, which passes through the point A, which is given 3 comma minus 3 comma 1, and it is and this plane is also perpendicular to the line L1, which joins the points B and C, where point B is 3 comma 4 comma minus 1 and C is 2 comma minus 1 comma 5. So therefore this plane is perpendicular to this line which joins B and C. So therefore the normal vector to the plane N1, that is along the vector BC. So we can tell that is equal to um, 2 minus 3 I cap plus, since y BC will be OC vector minus OB vector. So therefore that will be equal to OC, which is, so this is 2 minus 3 I cap, then plus minus 1 uh, minus 4 J cap, and plus 5 minus of minus 1, that is plus 1 K cap. So therefore N1 vector, so that will be equal to minus I cap minus 5 J cap uh, plus 6 K cap, or we can tell N1 vector that is equal to we can tell it is equal to some p times of this. um, so it is equal to p times this. So if we take p as minus 1, that will be equal to I cap plus 5 J cap minus 6 K cap. So then, and the plane contains the point OA, so therefore the required equation of the plane is will be r vector minus a vector dot n1 vector, that is equal to 0, where a vector is the position vector of the point A, which is lying on the plane, which is 3 I cap minus 3 J cap plus K cap. So therefore this equation we can write it as r vector dot n1 vector equals to a dot n1 vector. So therefore it will be r vector dot, which is I cap plus 5 J cap minus 6 K cap, that is equal to a dot n1. So a is, so it is 3 I cap minus 3 J cap plus K cap, and dot product it with I cap plus 5 J cap minus 6 K cap. So that will be r vector dot I cap plus 5 J cap minus 6 K cap, that is equal to 3, and so it will be 3, then minus 3 5 is a 15, then minus 6. So this will be equal to minus 18 actually. So therefore the equation of the plane we can write it as r vector dot I cap plus 5 J cap minus 6 K cap plus 18, that is equal to 0. And so this is the required vector equation of the plane, and in the Cartesian form we can write it as Cartesian form will be is r, so it will be x plus 5y minus 6z plus 18, that is equal to 0. So this is the required Cartesian form of the plane. So then we need to also find from the origin O, which is 0 comma 0 comma 0, coordinates of the foot of the perpendicular from the origin, which is M. So OM, suppose it is perpendicular to the plane pi1. So we need to find the coordinates of the point M, which is the foot of the perpendicular from the origin, and the equation of the perpendicular line OM. We have to find the equation of the perpendicular OM, and the length of the perpendicular also, means the length OM also we have to find. So now Um, so OM vector is perpendicular to the plane pi1. So we can say that OM vector will be parallel to the normal vector of the plane, which is n1 vector. So therefore, this OM vector, we can tell it as that will be some lambda, uh, times n1 vector. So that will be equal to lambda times n1, which is I cap plus 5j cap minus 6k cap. So therefore, if we take the point M as x1, y1, z1, suppose if you take point M as x1, y1, z1, then OM vector, therefore OM vector, that will be obviously x1 I cap plus y1 j cap plus z1 k cap. So this x1 I cap plus y1 j cap plus z1 k cap, that is equal to lambda I cap plus 5 lambda j cap, sorry, plus 5 lambda j cap, then minus 6 lambda k cap. So therefore, this x1 we can write it as lambda, y1 is 5 lambda, and z1 is minus 6 lambda. So therefore, the coordinates of the point M, we can take it as lambda, 5 lambda, minus 6 lambda. So now the point M lies on the plane. So it will satisfy the equation of the plane. So now, since the point M lies on the plane pi1, so it should also satisfy the equation of the plane. Equation of the plane. So we can tell so the equation of the plane is x plus 5y. Equation of the plane is x plus 5y minus 6z plus 18, that is equal to 0. And the equation and the point M is lambda 5 lambda, lambda 5 lambda, and minus 6 lambda. So therefore, if we put these coordinates here, then we will get lambda plus 5 into 5 lambda minus 6 into minus 6 lambda plus 18, that is equal to 0. So then we will get lambda plus 25 lambda, then plus 36 lambda plus 18, that is equal to 0. So then 37 plus 25, so this will be equal to 12, then 62. So 62 lambda, that is equal to 18. So lambda will be equal to so 62 lambda, that is equal to minus 18. So minus 18 by 62. So it will be 2 9s 18, 31. So therefore lambda will be equal to minus 9 by 31. So therefore the coordinates of the point M will be minus 9 by 31, 5. So 5 lambda will be equal to minus 5 times 45 by 31, and minus 6 lambda will be equal to 6 9s are 54, 54 by 31, minus 45 by 31, 54 by 31. So it will be the point M. Okay. Length of the perpendicular, coordinates of foot of the perpendicular. Okay, that we have found equation of the perpendicular line. So the equation of the perpendicular line PM that we have to find. No, it is, sorry, it is OM. Equation of the line OM. So that will be R vector equals to A vector, which is 0 vector, since the origin lies on the line OM. So it will be plus mu times of OM vector. So therefore R vector will be equal to mu into OM vector, which is minus 9 by 31 minus I cap minus 45 by 31 J cap plus 54 by 31 K cap, or therefore OM vector, the direction ratios along the OM vector is proportional to is proportional to that is 1, 5, minus 6. Therefore we can tell that the equation of the required equation of the perpendicular OM from the origin is R vector equals to mu into I cap plus 5 J cap minus 6 K cap. And in the Cartesian form, it will be in the Cartesian form, the equation will be x by 1, that is equal to y by 5 equals to z by minus 6. Then the length of the perpendicular from the origin, and therefore the length of OM, so that will be equal to the mod of OM vector. So OM vector is obviously OM vector, that is obviously lambda into, we got I cap plus 5 J cap minus 6 K cap. So lambda we got as minus 9 by 31. So that will be mod of lambda into the mod of I cap plus 5 J cap minus 6 K cap. So mod of lambda, that is 9 by 31. And this, the magnitude of this vector, that will be equal to the square root of 1 plus 5 square plus 6 square. So this will be equal to 9 by 31 into this will be square root of 1 plus 25 plus 36. So this will be equal to 9 by 31 into this is 26 plus 36. So this will be 262, which is square root of 62. So it is 9 root 2 by root 31. Since it is 2 root 2 into root 31, so it is 9 root 2 by root 31 units. So this is the length of OM. This is the equation of the perpendicular OM in the vector form, and this is in the Cartesian form. And the coordinates of the foot of the perpendicular from the origin is this OM. And the equation of the plane, that is this. So all these are the answers. This is also the answer, and this is also the answer. So thank you.